The first question in your practice from the Pythagorean theorem. There's these special triangles, specifically special right triangles, where I like to think of them more as like shortcuts. So they help you find the missing sides a little quicker than using the Pythagorean theorem, things like that. So when you're solving a triangle, essentially what you're doing is you're finding all the angles and all the sides. Okay? And we can use these special right triangles to help us find the missing parts of triangles a little quicker. One particular special right triangle is a 45, 45, 90 right triangle, meaning that the acute angles are 45 degrees, and the third angle is 90. 45, 45, 90 right triangle. Okay. The length of the hypotenuse is radical 2 times the length of a leg. Okay, what that means, if we have a triangle where two angles are the same, what do we know about the two sides? They're the same. So across from this 45, this side and this side are the same. I'm just labeling them a generic way. You'll have to deal with actual numbers here in a minute. But I'm just labeling those sides with X. Okay? And we know the length of the hypotenuse is radical 2 times the leg. So literally, you take whatever the leg is, and you're writing radical 2 next to it. Because with radicals, when you multiply them, if they're not the same, you literally just stick it next to it. Okay? So when you're multiplying like a number and a radical, it's literally that number written next to that radical. Okay? You are going to be given this diagram. Okay, the OSC gives you a reference sheet and they have this diagram on there. So you don't necessarily have to memorize it. Okay? You just have to be able to apply. Okay? Little tricks. If you're given a leg and you're trying to find the hypotenuse, all you have to do is multiply the leg by radical 2. And you have your answer. And when I mean multiply, you just write it next to it. Okay? If you're going from the hypotenuse to a leg, you do the opposite. So instead of multiplying by radical 2, you just divide by radical 2. You'll see an example here in a second. So if we're going from small to big, how do you make something bigger? Do you multiply or do you divide? Multiply. So if you're going from small to big, multiply by radical 2. If we're going from big to small, how do you make something smaller? Divide. So we're dividing by radical 2. Okay? Algebraically, to show how this works, okay, we use this diagram. Okay? How we can show algebraically that this works. We have our legs, which are our A and our B. What do we label our hypotenuse as? C. Okay? Well, if I do x squared for a squared, because I'm just using the Pythagorean theorem to show that it works. Okay? We said our legs are x and x, so I'm just doing x squared plus x squared equals, what's our c? X radical 2 squared. Okay? We get the same thing on both sides, and we know this works. Okay? So here, we can't really simplify anything down, but what's x squared plus x squared? 2x squared is equal to, when we square here, when we're multiplying inside our parentheses, this is where we can distribute that exponent. So when we raise x to the second power, we just get what? X squared. And what did we say? When we square square root, what happens to that radical? It goes away, so we're just left with 2. Well, what's x squared times 2? So did we get 2x squared equals 2x squared? That's why it works. And it's going to work every single time. You maybe noticed when you did the Pythagorean theorem in your practice how when your legs were the same, like in the first one, both legs were 4, and your answer ended up being 4 radical 2. Okay? This is a shortcut to that. You still can use the Pythagorean theorem if you're given the legs to get the right answer, but this is more of a shortcut. So now we can see some examples of this. Okay? We're going to solve each of the triangles. Again, when it says that, you have to find all the angle measures, and you have to find all the side measures. Okay? Even if there's not a variable written there, you still have to find it. So first, I like to find the angles. If this is 90 and this is 45, what does that have to be? 45. So we found that angle. So we know we have a 45, 45, 90 right triangle. So ask yourself, were we given a leg or were we given a hypotenuse? Leg. Okay? So we have a 45, 45, 90 right triangle. What do we know about the two legs? They're equal. So this is 9. This guy's going to be 9. If we look back at our diagram, okay, if we're going from leg to hypotenuse, what are we multiplying the leg by? Radical 2. So you literally, when we say multiply by radical 2, you're not going to type 9 times radical 2 in your calculator and round. Literally, all you have to do is take whatever the number of the leg is, and you write radical 2 next to it. Done. Because if the angles are the same, we know the sides are the same. And if we know we have a 45, 45, 90 right triangle, we automatically know the legs are the same, no matter what. So whatever one leg is, the other one has to be that. Yeah, it's a 45, 45, 90. So if we look at B, again, we're going to solve for the angles first. So again, if this is 45, this is 90, what does this have to be? 45, all the time. Were we given a leg or were we given a hypotenuse? Leg. Okay? So what do we know? What is this other piece? If this is 2 radical 2, what does our other leg have to be? 2 radical 2. If we're going from leg to hypotenuse, are we multiplying or are we dividing? Multiplying. What are we multiplying our leg by? Radical 2. Here's the thing. If it was just a number, like we did here, we can just write radical 2 next to it. But does this look right? Does that look like something you see in math? No. Again, because we're multiplying those together. Alright? When you multiply radical 2 and radical 2 next to each other, what do we get? Radical 2 times, you just get 2. Same as squaring. When you're multiplying two radicals that are the same together, it just cancels out their radical and you're just left with a number underneath. You can even check in your calculator. Radical 2 times radical 2 will be 2. And then what's 2 times 2? 4. So I know that side equals 4. Sometimes that happens. Sometimes your leg has a radical in it. There you actually have to multiply things out. But if it's just a number, you just do what we did in A. Literally just write the radical next to the number. If we take a look at 2A, were we given the leg or were we given the hypotenuse? Hypotenuse, right? So if we were given the hypotenuse, are we multiplying or dividing? Dividing. What are we dividing by? Radical 2. This is really nice because what happens to our radical 2's? They go away. Gone. So we're just left with what? 4. Okay. Well, and we forgot this is 45, this is 90, that's supposed to be 45. And it's nice when we have 45, 45, 90 because once we get one leg, what do we know about the other one? It has to be what? The same. Yes.
Hypotenuse is just the number in radical 2 and just give the same hypotenuse is 4 radical 2, but it's small.
Yes. But B can't get what it's at. So you have to do this in B. Okay. Again, in B, were we given the leg or the hypotenuse? hypotenuse. So what do we have to divide by? Radical 2. Here's the thing. Is there anything to cancel that radical 2 out? No. And I'm not sure if you talked about this in Algebra 1, but a big thing with radicals, they can't be in the denominator. They're not allowed to be. So to get rid of them, what you have to do is you have to multiply the top and bottom by whatever radical's in the bottom. It gets rid of it. Okay? Again, we can't multiply the 6 and the radical 2 together. They both have to be underneath the radical. So this does not become radical 12. It literally just says 6 radical 2. You just leave it like that. Okay. In the bottom, what did we say what happens when you multiply the same radical together? What happens to it? It goes away and you're just left with 2. Can we clean this up even more? Yeah, because what does 6 over 2 simplify down to? 3. So this becomes 3 radical 2, which means this is 3 radical 2, and this is 3 radical 2, and this angle have to be 45. So when that happens, when you're given the hypotenuse, if you're dividing by radical 2, and it doesn't cancel out like x, you have this what we call rationalizing. Okay? A shortcut to rationalizing, what you can do. So shortcut. Okay? Whatever number's in the bottom. What's 6 divided by 2? And what did we write next to the 3? Radical 2. So a way to check your answer or a shortcut. Whatever number's in the bottom, 6 divided by 2 is 3. Tack on the radical in the bottom, that's going to be your answer. Okay? Sometimes it's nice and neat and clean. Sometimes if this was like a 7, can 7 and 2 simplify? So you just leave it as 7 over 2 radical 2 using your shortcut. 7 divided by 2 is just 7 divided by 2, tack on the radical. Okay? If you don't remember the shortcut, just multiply the top and bottom by the radical in the denominator, clean it up. Okay? Yes. When you're dividing. So all those are your radical 2 at the end of it. Okay. There is this other special type of right triangle. It is a 30, 60, 90 right triangle. Okay? Meaning, one of the angles is 30 and the other angle is 60. Any 30, 60, 90 triangle, the length of the hypotenuse is 2 times the length of the shorter leg. The shorter leg is the one that's always across from the 30. Okay? That's our main leg. That's the leg we want if we don't have it. Okay? So I'm going to label the side across from the 30 with X. That's our main side in a 30, 60, 90 right triangle. Okay? In order to get the hypotenuse, all you have to do is just multiply the short side by 2. Just double it, and that's your hypotenuse. Okay? The length of the longer side, so the one across from the 60 is what's a little tricky. It is radical 3 times the length of the shorter leg. So you're going to, if you're given the shorter leg, whatever it is, you're multiplying it by radical 3 to get the longer. Okay. Radical 3. So similar to 45, 45, 90 right triangles, again, if you're going from small to big, are you going to multiply or divide? Multiply. So if you're going from small to big, you're multiplying. So go from the short to hypotenuse, multiply by 2. Short or hypotenuse to short, instead of multiplying by 2, we're going to divide by 2. Small to big, multiply. Big to small, divide. If we are going from short leg to long leg, we're going to multiply by radical 3. If we're going from long leg to short leg, we're going to divide by radical 3. Okay. Again, algebraically, to show that this works, we're just going to plug it into the Pythagorean theorem. Okay. Which leg are we going to label with our C? Which one's our hypotenuse? 2x. Does it matter which one's your A or which one's your B? Nope. I would say A. So we plug it in, we get x squared plus x radical 3 squared is equal to 2x squared. X squared is just going to stay x squared. We can't do anything with that. But when we square this, again, we can, because we're multiplying, distribute that exponent. When we square x, we just get x squared times, what happens to this radical when we square it? Goes away. We're just left with 3. Again, we're multiplying, so we can distribute that radical. When we do so, 2 squared is what? 4. When we square the x, we get x squared. Clean it up. X squared plus 3x squared is equal to 4x squared. And what's x squared plus 3x squared? It's 4x squared. So it works. It's going to work every single time. No matter what. Okay, questions? Now we're going to see how this looks in some examples. Okay, we're solving these triangles. So we're finding the missing angles and sides. Again, with these, you always have to leave your answer in simplest radical form. If we look at A, our angles are already given to us. Our 90, our 30, and our 60. So you have to identify which side was I given. Short, long, or hypotenuse? Short. How do we know it's the short side? It's cross from the 30. I love getting the short side. P5s, I think it's the easiest one to do. Okay. If we're given the short side, what do we have to do with 5 to get our hypotenuse? Multiply it by 2. 5 times 2 is what? 10. So we know our hypotenuse is 10. Okay. Go back to your short side. What do we have to do with our short side to get the long side? And are we going to type 5 times radical 3 in our calculator? No. You literally just have to do 5 radical 3. Done. Well, I'll get the short side. Pretty easy. We look at B. Were we given the short side, the long side, or the hypotenuse? Hypotenuse. So, again, which side, if we're not given it, do we have to find first? The short side. What do we have to do with the 14 to get the short side? Divide by 2. Hypotenuse to short, divide by 2. And what do we get when we do 14 divided by 2? Now that we have our short side, we can use that to find our long side. So you just go back to our short side. What do we have to multiply 7 by to get our long side? Radical 3. And you don't actually multiply, you just write it next to it. So. In C, if this angle is 60, this angle is 90, what does this angle have to be? 30. We got that angle. We didn't have to find the angles in the other ones because they were given to us. So ask yourself, was I given the hypotenuse, the short side, or the long side? Long side. So again, we have to go from long to short. Are we multiplying or dividing? Dividing. What are we dividing by to go from long to short? Radical 3. Yep. get that radical out of the bottom. Multiply by radical 3. We can't multiply the top together, so you just leave it as 6 radical 3. What does the bottom become? 3. And then can we clean this up some more? Yeah, it becomes 2 radical 3. So that is our short side. You always find that first if it's not given. Then once you have your short side, you can find the other one. Okay? To go from short to hypotenuse, are you multiplying or dividing? Multiplying. And what are we multiplying by? 2. Okay, so we're taking our short side and we're multiplying it by 2. When we do that, you're just multiplying the number out in front by 2. So 2 times 2 is 4. Tack on the radical 3. You can't, unless it's underneath a radical, you can't multiply the numbers together. So you can't, like 2 radical 3 is not radical 6. So these are a little bit trickier, okay? Because there's multiple triangles within one, okay? So I'm just gonna pick one. I'm gonna pick this one over here. I'm gonna highlight it, and I'm gonna figure out the angles first. So I look at this yellow triangle. Okay, it only gave us 60, but if you look here, this is a 90-degree angle. So what does this one on the inside also have to be? 90. So I'm going to mark that. Okay. And if this is 60 and this is 90, what does this little one have to be? 30. So we have our 30, 60, 90 right triangle. Which side were we given? Okay. Short side. I love getting the short side. Okay. Because all we're doing is multiplying once we get the short side. So to get the hypotenuse, what do we have to multiply the short side by? 2. 2 times 7 is 14. So we just leave it as 14 radical 3. To go from the short side to the long side, what do we multiply by? Radical 3. So we have to do 7 radical 3 times radical 3. Again, what happens to our radicals when we multiply by the same thing? Cancel out, so we're just left with 3. 7 times 3 is what? 21. So we know this leg right here is 21. And that will help us out with finding the other missing pieces in this other triangle. Okay? So we have this blue triangle right here. Okay? So I know this is 90 and this is 30. What does this have to be? 60. I'm going to label this angle with 60. And what were we given in this blue triangle? Short side, long side, or hypotenuse? Short. Yeah, what's our short side? 21. So what do we have to do with 21 to find this side right here? Times it by 2. So 21 times 2 gives us what? 42. Go back to your short side. What do we have to multiply our short side by to find our long side? Radical 3. Literally, you just tack on a radical 3. Sometimes they're kind of like old puzzles. 2 triangles. If we take a look at about this bottom triangle? Were we given any of the sides? So is that a good one to start with? No. I'm going to start with this top one, this yellow one, because it at least gave me one side. And what kind of triangle is that top yellow one? 30, 60, 90. Right? If one angle is 30, one angle is 90, then I know that other one has to be 60. In which side were we given? Short, long, or hypotenuse? Hypotenuse. Across from the 90. So we always want to find which side first? Short. So to go from hypotenuse to the short side, are we multiplying or dividing? Dividing. What are we dividing by? 2. 12 divided by 2 is 6. So I know the short side is 6. Now we have to find the long side. To go back to your short, what are we multiplying 6 by to get the long sides? 6 radical 3. You literally just tack it on. Okay. So now we're going to take a look at that bottom triangle. This blue triangle. What kind of triangle is the blue triangle? 45, 45, 90. If I know this is 45. If one's 45, one's 90, the other one has to be 45. Were we given a leg or a hypotenuse in a 45, 45, 90? A leg. So if this leg is 6 radical 3, what does y have to be? Right. And in a 45, 45, 90, what do we multiply the legs by to get the hypotenuse? 2. So we do 6 radical 3 times radical 2. We can multiply the 6 and the 3 together because they're both underneath radicals. 3 times 2 is what? So that just becomes radical 6. So it's just 6 radical 6.